live.
Hello and welcome everyone. This is Aurora with the Central Coast Astronomical Society, and I'm so excited that you're going to be joining us. We're actually a little bit early and we are just going to make sure that our audio is working great and our videos are working great, but I'm very excited that you are joining me tonight. So we have a couple of special surprises and a couple of special guests that I'm going to introduce at the top of the hour. Before we get started, I just wanted to, if this is your first time joining us tonight, I want to extend a special welcome to you. And if you have the downloads that were listed, they're underneath this video. Now, if you're watching this on YouTube, you'll have to go back to the Central Coast Astronomy website. Or in the YouTube, that also should be in the comments section as well. There will be links, and you can download our handout that will go with the session that we're doing tonight. There's two different versions, one with no pictures whatsoever to save on ink, and this is the full-blown version. It's like 12 pages long. So Kent and I put this together for you, and this will, there's a lot of room in here. I've also left room so you can take notes as we go through. Grab a pencil and your handout. Now, if you don't have the ability to print this out, don't worry. It's not a test. I'm not going to collect it. This is just for you. At the end of our session tonight, you will be able to go outside, look up, and really know what you're looking at. And so that's really exciting. If you do have a pair of binoculars, you absolutely can use those. We are going to focus on objects you can see with your naked eye, as well as objects you can see with a pair of binoculars or a small telescope. And by small, I mean like small, like 4 inches or less. So pretty small stuff. Now, if you can do me a favor, do you see the comment section, especially if you're watching us on YouTube? If you would like to be able to interact and talk with us and ask our astronomer friends questions, go ahead and you can use the comment box just to talk to and to ask us questions in there. Brian will be our moderator for tonight, so everyone give a big warm welcome to Brian and a kudos and a thank you to him. He's going to be helping answer those questions as well, in addition to Kent and myself. And so if you could right now just go ahead and type in your name and also where you're from, so we can kind of just get the chat box working, make sure everything's going well. Let us know how the sound is and how it looks. That would be really helpful. So you can go ahead and do that right now. And we've still got about 4 more minutes. So really quick, I know a number of you are also joining me from my science camp. And so for those of you who are joining me from Supercharged Science, I want to extend a special welcome to you. This is actually going to piggyback on some of the astronomy labs we've already been doing. And so I can point out a little bit of that later on as we go down the line. And so it's for some of the additional labs that you'll be doing. So hello everyone. Hello to Teresa from Mojave River Valley and Victorville. Hello. We have folks watching from Australia and Celeste and Maria from Los Angeles. Hello, welcome. Sounds good. Okay, that's great. We have some folks from Thousand Oaks and Oxnard and California. Oh boy, here everybody's coming in. Hello, we have Truman from Vegas. And so I want to extend a special welcome to everyone. My name is Aurora. I am the president of the Central Coast Astronomical Society, and it's really my pleasure to be able to bring these resources to you and just to share in the wonder and the amazingness of the universe that we live in. Oh, and the other thing I meant to mention, I kind of forgot. If you printed out your evening star map, you can totally use that tonight. This works well if you have a highlighter. So pencil works kind of good, but it's kind of busy already on here. And so if you have a highlighter, you can go ahead and get that out and use it with your star map if you've already printed that out. It was another link that was next to the handout as well. So if you've got the handout, that's great, take it out. If you've also got your star map, take that out. We're going to be highlighting the constellations we're going to focus on just for July. And as we go through, you can make like little marks in there and little notes to yourself of where to look when you go outside tonight. If you've never used one of these things, it can be pretty scary looking. It's real simple. You'll notice around the circumference, it says north, south, west, and east. So this thing goes over your head like this when you're outside, and this is what you're going to see when you look up. And so you just make sure the north is really pointing north and the west is really pointing west. And you hold it over your head, and then that's what the sky should look like if you were lying flat on your back looking up. And that's how you use these things. Okay, so we are getting near the top of the hour. For those of you who have just joined us, welcome. My name's Aurora. I'm president of the Central Coast Astronomical Society. We have over 7,000 people that have said, hey, I'm interested. I want to join you tonight. And that's a lot of people. So thank you so much for joining. I'm just so amazed by how many people are interested. So if you know of anybody who would love to do stargazing with us tonight, give them this link and let them know. You can subscribe to our channel, you can like us, you can follow us, all that social media stuff. Feel free to do that as well. We also have a Facebook page, and here is our official website. For those of you who have been to it, it's haven't been to it, centralcoastastronomy.org, O-R-G. centralcoastastronomy.org. You can go ahead and just print that on write it down on your handout if you'd like. We have stargazing. You click on that and it'll tell you all the stargazing sessions we have, as well as guest speakers that we have, as well as information like, for example, the comet that we're going to start out with tonight. Okay, so that's us here at Central Coast Astronomy. This is fun, free, and it's open for all ages. As I mentioned before, we have a we have quite a few people joining us also that are a part of I have an online science program, and so we also have been doing astronomy. And for those of you who have been participating in our astronomy labs, your lessons look like this. And this is a kid program that is available for kids and during the summer program as well as in the fall. So tonight's stargazing session really dovetails in with what we've been doing. You can get more information about that at www.superchargedscience.com. Okay, you guys ready to get started? If you are, rub your hands together, say, oh yeah, we're gonna have some fun tonight. Okay, so hello, welcome. My name is Aurora with Central Coast Astronomical Society. We are going to be doing stargazing. Isn't that fun? It's like nothing says summer more than like the hot summer nights and the twinkly stars. It's going to be so much fun. So if you've got a bowl of popcorn, get it out and give me some. So again, if you printed out your handouts, this is something I put together, Kent and I put together for you. You'll be able to look at that as well. If you have questions anytime during the session, type them in that box. Go ahead and drop me a note right now, drop it in the box, and if you're ready, say, oh yeah, tell me where you're from and what part of the country or what part of the world you are watching from, so we get an idea of what kind of stargazing to focus on. And so that helps us, and we do watch that as we are going through, so that makes logical sense. We picked this weekend because the moon is very, very, very small and it's not up, which is great because that means we can see more stars. And people often think, where should I go to see the stars? You just want to get to a dark spot. It could be on the side of the road. It doesn't matter. Get out of the city lights and then just look up. Using tonight's information, you'll be able to know what you're looking at, and it's so amazing. Speaking of which, how many of you have actually seen the comet? Anybody out there seen the comet? If you have, just drop it in the chat box right now and just tell me if you've seen it. It's a naked eye object. You can get beautiful images of it right now, just with some simple camera equipment. You can also use binoculars to see it. And I actually did that last night. You don't need great big binoculars like this. You can just use regular old binoculars to take a look at it. And I'm going to bring on someone here in just a minute. His name is Brian. He's from the Riverside Astronomy Society. And he has been helping us out a lot since we haven't been able to stargaze in person. He's been helping us a lot with our online efforts. And so his name is Brian, and I'm going to bring him on in just a second here. And I'm going to share my screen so you'll be able to actually see him. And he is going to share with you a video that he took of the comet, and he's just going to talk to you about it and answer some basic questions that have been coming in. Brian, are you ready?
I'm ready.
All right, take it away.
All right. Hi, Aurora. So it's actually going to be a picture, not quite a video, although that would be pretty cool. I'll have to work on that.
Oh, did I say video? I'm so sorry.
No problem. Well, thanks, Aurora. Yeah, this is Comet, ready for the name, 2020 F3 Neowise. And it's quite the name. It's rare anymore where we get to name comets after people, although it does happen. Most of the time they're named after robotic surveys that are looking across the sky all the time. And that's where this comet gets its name. So let me share with you a picture I took, when it was first started to become visible for us on the north side of the equator. You had to get up quite early. And I actually had to get up at, yes, 4 o'clock in the morning to get this picture. So this is a picture here of this comet. This was taken at about 4:30, and it's a really beautiful comet. This was actually naked eye at that time. This was on July 11th. Naked eye meaning that I didn't need to use my camera magnification, binoculars, anything. I could pick it out. But what I did do is I took picture, and when a camera showed me where to look, I did have to get a little hint to know where to look. But once I knew, I could see it naked eye. So this comet now, thank goodness, is actually visible in the evening sky. And so what I want to do is take a moment to share with you where you would need to look in order to see it. So I'm going to switch my screen around. So this is a view out of Stellarium, which I know you're going to be using to show us lots of different things. So here, let's see if we can recognize where we are. So we know from our little compass, we're looking to the northwest. So what you want to do, this is the view from San Luis Obispo tonight at 9:30. After the sun goes down, while it's still some twilight, take a look to the northwest. And as it gets darker and darker, you can start looking for that comet. And let's see if we can see a familiar constellation. I'm going to change my view here. Looking straight up from the northwest, there is the bowl of the Big Dipper. So we have the Big Dipper, and then of course we could arc off to Arcturus. But the Big Dipper is coming straight down from there. This is where the comet will be. And from this location, that's where you should see it tonight. Now you can notice this little black line at the bottom, that's the horizon. So we don't get a whole lot of time. For instance, just an hour later, at 10:30, this is where it's going to be. 10:30, and then this is 11:30, and it's going to be too low to see. So starting about 9:30 is when it'll be starting to get dark enough, and then you'll be able to look right here. Now, how long do we have for this comet? Before I share that with you, let me tell you a couple other things about it. This comet, we're estimating, is about 3 miles wide, or 5 kilometers. So I'm glad it's far away. We can let it be nice and away for us to observe its beauty. You want to go out and take a look at this comet now, because it's going to be about 6,766 years before we'll see that comet again.
Oh my.
So save the date. But I think you're better off to go look for it now. And you know, the big thing about comets is it can be difficult to estimate their exact brightness, or what we'd call magnitude. And sometimes they fall apart. And so you want to go any chance you can to go take a look. Now, between July 22nd and 23rd, not too far from here, from this date here, we're at the 18th, that's when the comet will be closest to us, to Earth, on its way out of the solar system. So let's advance the days so you can see where it will end up on that day. Notice here's the 19th, 20th, and then here's the 22nd. So it's moving slightly up in the sky from our view, and a little bit to the left from our view of the scoop for the Big Dipper, and of course to the left from our view of Ursa Major. So the nice thing is, as it comes closer to us, it'll move higher in the sky, so we'll have a little more chance to see it before it sets, but we don't know how bright it will be at that time. So we want to take any chance we can. All right. And by the way, the time zones that I'm showing for the comet here, that's for Pacific Daylight Time. So we're here on the West Coast. All right. So
Awesome.
Any questions? There you see, I'm looking for...
Wow. You got a lot of people who are so excited and had no idea the comet was out.
Yes. Yeah. And, you know, by the way, so I'm in Oak Hills, California, which is, let's say about 30 miles east of Los Angeles. I'm in what's called the high desert. So I'm about 3,000 feet altitude. Mm-hmm. For me, it's actually a naked eye object in the evenings. So I'm pretty excited about that.
Wow.
And I've been working on some pictures, but I've been so busy observing. By the way, look through it any way you can. binoculars, telescope, naked eye through a camera. And it's nice because it's so bright. You don't need any specialized equipment, or as you mentioned, a regular camera where you can use a tripod to take a few second exposure and you'll get it from there.
That's right. That's right. Awesome. Well, thank you so much, Brian. You know, before we bring Kent on, I just wanted to let people know that you can actually make a comet if you know how to do a little bit of chemistry. Did you know that? Uh-oh.
Yes,
I think I lost him. So I actually made a comet here and showed people how to do it.
In
Whoops.
30 minutes.
And you can actually see, using a bit of chemistry, we've got some frozen gases in here. And that's me in the daytime. And I'm actually showing, you can actually see it sublimating there. And let's see, it even has a tail at one point. Where is it? Maybe I can't show you the tail. Anyway, there's one point where I blow on it and the whole thing just has a big old tail that comes off the end of it. So, so that's a cool science experiment that you can do with kids to get them interested and excited to do to astronomy. But that's just me because I like kids. Okay. All right, awesome. So you guys ready? We are going to be doing even more of our stargazing. Get out your pencils, get out your questions that you're going to type into us. We are ready to bring on our main feature for tonight, and let's see if I can find him. Kent, where are you? Are you here?
I'm here. Yeah.
Woohoo! Welcome, Kent. So Kent
Thank you.
Yes, thank you so much for being with us. Now, Kent is, I don't even know how to describe it. He's just amazing. And when I first started in astronomy, maybe 15 years ago, I would park myself next to him because he's the type of person who you can ask any question to, like, what about this and what about that, or where do I look here? And he's like, oh yeah, you look over here, and he's just this incredible wealth of knowledge. And I wanted to be able to give that resource to you so you can have that too. And so I'm really excited. Go ahead, Kent.
I wanted to thank Brian for the comet thing because I've tried to see it and haven't had any luck.
Awesome. Yes, quite a few people are saying thank you so much for the comment. So thank you. All right. So Kent, tell us really quickly before we get started, what kind of telescope do you like to use?
The easiest is my old C8, which is a Celestron 8-inch Schmidt-Cassegrain.
And let's see if I can find a picture. Oh, there you are. And so you just got started with a little telescope like this?
Actually, I started with a Sears 60 millimeter refractor.
Oh, that's right.
Back in about 1969 or 70. And that's the beast there, the 20-inch.
Mm-hmm. Nice. So, Ken, what do you really like to look at when you go stargazing? What is your personal? Give us a little background about yourself before we dive into stargazing for tonight, so folks can get to know you a little better.
Oh, for tonight?
Yeah.
Other than the comet, which I'll probably go out with my binoculars around 9:30 and see if I can see it, would be Jupiter. Mm-hmm. Jupiter, and then Saturn is about a binocular field to the east from those. So those would be the two I'd start off with, is Jupiter and Saturn, just because they happen to be over into the southeast now.
Got it.
So those would be the two I'd start with.
Okay, great. So for those of you who may be wondering, why am I just showing pictures of Kent and why can't you see him? Kent is on a rotary phone. And so it's a little bit of a trick to get this connected, but we did it. We're very proud about that. And also, Kent is using his knowledge from his head. He's not looking at star charts while we talk. He's actually going to be just sharing his wealth of information with us. And then I am going to be using the planetarium software that is free and available for everyone. It's called Stellarium, like stellar, S-T-E-L-L-A-R, and then I-U-M, Stellarium. And so I'm going to be navigating that. So he's going to be talking to you, and then I'm going to drive the controls for the planet. It's like an indoor planetarium. And I'm going to drive the controls so you actually see where to look. And we'll be going back and forth with images and so forth. So are you ready, Kent? You ready to start? We might as well start with the ones you mentioned.
Yeah,
Are you ready?
Let's get going, yeah.
All right, let's do it. Here we go. Okay, so let me share my screen. And Kent, why don't you get started talking and tell us what we should be looking at tonight?
Okay, let's see. Right off the bat, you mentioned the moon is 2 days from new. So that's really good. That means it's going to be nice and dark out for viewing. And we talked about Jupiter and Saturn are up. The interesting thing about Jupiter is that the moons are usually in a straight line because Jupiter's its axis is almost perpendicular to the plane of the solar system. So you always see them in a straight line. Where Saturn, they're usually scattered around because Saturn has a significant tilt with respect to the plane of the solar system.
So let me see if I can actually zoom in on Jupiter. Okay, so here we go. And you can actually see how, well, if we get rid of the names, you'll be able to actually see how Jupiter, the large one here, and all of the moons are in a straight line. Okay, and if we go over to Saturn, okay, Kent, you can keep talking.
Yeah, I was just looking at the picture you got there.
There we go.
And you can see how close the two are. They're not that far away. I can usually, just by nudging around my binoculars, I can get both of them into the same field. So, and there's the moons. You can see they're pretty well, they'll be like 2 on one side, 2 on the other, or 4 on one side, or 3 of them, one's hiding behind Jupiter. But they're pretty well lined up with the bands on Jupiter. Where Saturn's a whole nother story. Saturn, they're scattered around all over the place because of the tilt of Saturn, except when the rings are edge on. When the rings are, it happens like twice in orbit. I think it's every, 12 years, something like that. The rings get totally edge on, so all you see is a line. Then all the moons line up, which is really cool to see. And, it's an infrequent thing, but most of the times the moons will be scattered around Saturn.
Perfect. Okay, great. So when you're watching, are you watching the YouTube right now?
Yeah, I've got it on the screen here.
Okay, great. So
and I don't know what the delay is, or if there's any delay, but there may be a little bit of delay.
it should be pretty low for you tonight. It shouldn't be like it's been in the past. So you should be seeing Saturn right now.
Yeah, in fact, you got Saturn there. Probably that bright moon to the lower right, or lower left, I mean, is probably like Titan.
Yes, very
That's
good.
the big bright one.
Mm-hmm.
And then you see a few more moons scattered around. In my 20-inch, you can pick up those fainter moons.
Wow, that's amazing.
For Jupiter, even an 8-inch will show the 4 Galilean moons.
Well, you can actually see that with binoculars, right?
Not my binoculars.
Oh.
I don't know. I think your big binoculars would probably pull it in. You've got the 100-millimeter ones, I believe.
I do.
And also, you're like 20 magnification, so you shouldn't have any problem pulling in the moons around Jupiter. You might even be able to pull in Titan around Saturn there.
Okay. Okay, very good.
And so, those I just want to bring up before we get into the constellation. Those are the 2 big ones that are up right now.
Perfect.
And so for constellations, I figure, start with Libra, which is down south, and that's that one that has the unpronounceable names for the alpha and beta stars.
Yes.
It's Arabic, and I think it's like Zubenismali or something like that. But, best to use alpha and beta. It's a lot easier.
Yes.
And one means the alpha is a southern claw, the beta is a northern claw. At one time, the stars that make up Libra, or the scales, were the claws of Scorpius. And it was the Romans who sliced it off and made them the scales, kind of shortened down poor old Scorpius there.
Yep. And so for folks that have maybe aren't familiar with stellarium, what we're showing right now is the night sky. You can see the Milky Way band here. This is only something you're going to see with really dark skies, not in a big city like New York. But this is a really dark sky right now that I'm showing you, and it has a lot of stars in it. And if you look at the little red compass headings here, this one says south and this one says southwest. So from the northern hemisphere tonight, if you walk outside and you look between south and southwest, and you look straight up, you will see, well, you'll actually probably see this big star first. People sometimes think it's Mars. It's not. It's Antares. That's part of Scorpio. We're going to talk about that. But the constellation we're going to focus on right now, you see this diamond pattern? Okay, so that's Libra. Now, normally, you will not be able to see the dots connected, right? Or the names. So let's do this without any of the fancy stuff. Typically, you're going to see this. And so this can be really confusing. Like, well, how do I know what I'm looking at, right? So, and I look around and just more dots, right? Okay, so this is how we're going to do things. So we're going to look for certain, signposts. We're going to look for certain familiar patterns that you'll be able to pick out. And this is true even if you're in a city. So you're going to go outside tonight from the northern hemisphere. You're going to look kind of due south, and you're going to look straight up over the horizon. And you're going to see a really bright star. So that's going to be Antares. It's going to have kind of an orange-red glow. Would you say, Kent, more orange or more red for Antares?
Yeah, orangish color. It's relatively bright. It's a first magnitude star.
Yeah, it's really bright. So
and Antares is really big. I mean, it's I think they were saying it was something like 4 astronomical units in diameter, so
wow.
That would put it out there a ways. Actually it's 4 in radius. That's right. So it'd be 8 in diameter. So its surface would be probably in the asteroid belt, beyond Mars.
So if we replaced our sun with this one, the sun would be all clear out to the asteroid belt or further.
Yeah, Antares, the surface, it's like 600 light years away, so it's way out there.
Wow.
And it's what they call supergiant M-class star. And, it's red, but it's really bloated.
Yes.
And, it kind of falls in the category of going to go supernova someday. But the thing that's amazing is how the constellation of Scorpius actually looks like a scorpion, the shape of it.
It does.
Antares, they call it the heart of the scorpion, but the Greek, it really means like Mars. It has a reddish color or orangish color like Mars. And so it, translates like Mars or like Ares.
Right.
Or Antares. Ares is the Greek god of war. And so that's where it comes from, is the Greek.
Perfect.
And, that's basic how the thing goes. There's a story. I guess we should get the mythology.
Well, wait. Hang on. I was just going to do a signpost. Wait, don't do the mythology yet. Hang on. Let's.
Okay, no problem.
Okay, wait.
No,
I want to hear what you have to say. Let me finish this really quick. So for people that are new, when you go outside and you look between south and southwest, you'll see a bright red star, orange star, and you'll also see a little bit lower, like a whitish blue star. Okay, so this is going to be Spica. This is going to be Antares. So if you look here and I connect the dots, do you see where the diamond is? Do you see that's between the two of them? This is the constellation we're going to be talking about first, and then we're going to talk about this constellation over here, Scorpio. So if I turn this off, can you find it? Can you find that diamond? Here, I'll turn it on again and turn on the names. We're looking for Libra. Libra is this one. Okay, so when you go outside tonight, here, I'll shake up the sky a little bit. There we go. Okay, you're going to go out, look between south and southwest, find a bright orange, a bright white. These are going to be the brightest stars in the sky. Look in the middle. Can you find the diamond? Can you get it? Did you get kind of close? The stars are not very notable in Libra, are they, Kent?
No, it's kind of a sad constellation. It's really not one that, it's got a few faint objects in it, but it doesn't have any nice binocular objects in it.
Okay, now
but
go ahead.
I was thinking also for showing the scorpion there, another big way of finding it is look at the Milky Way. It goes right through. I mean, you can't miss the Milky Way if you're somewhere dark. And it goes right through the Scorpion there.
Perfect. Yep. Now, can you find the Scorpion? You see the bright star? It's due south. You're just going to look up. You're going to find Antares, which is that bright orange star. And then you're going to look for a kind of a backwards question mark. Not like Leo the Lion, but this one is lower in the horizon. That's going to be the tail of Scorpio. Okay, so Kent, you want to move on to Scorpio, or did you want to mention any more things about the...
Let's, the thing that's neat about Scorpio is or Scorpius, is it really looks like a scorpion. In fact, those two little stars at the end of the tail are the stinger, or is the stinger. Also, there's when you make that first drop down and you make the first curve, there's the false comet, which when you look at it with binoculars, it really does look kind of like a comet. It's just a grouping of, actually it's an association of stars in there. And you can see it right at where the first curve begins down there. They call it the false comet, or also I've heard the name the table of Scorpius, believe it or not. And there is a really nice, not binocular, but telescopic cluster in there. I think it's 6231.
Yes. Oh my gosh. Yes, you're right. Here, let me highlight it on the window.
6231. There's a very tight, very young, really nice cluster in a telescope. You're going to see the false comet in binoculars, but that cluster, if you get a nice telescope on it, even a small telescope, it really is pretty to look at. And so that's a nice thing about the false comet. And then I always like the stinger at the end of the tail of the Scorpion. That's always kind of cool to have those two end stars there. So it really does look like a scorpion. There you're getting it. Now, it's a really young cluster with a lot of bright stars. And in fact, you can see that H2 region up above, that red region. That whole area is what they call an association of stars. It's got a lot of very hot, very bright stars in it.
Awesome. So you mentioned H2. Did you want to talk about that for a minute?
Okay. H2 means singly ionized hydrogen. When you see the astrophotos that show red for a nebula, that's the ionized hydrogen in most respects. And you can see a few of them. In fact, Aurora's blowing it up there where you can get that nice little H2 region there. And I see it, or actually the film sees it best as a red nebula, but it's actually the reason they call it H2 is H1 is neutral hydrogen. It has its electron, where H2 actually the electron's been knocked out. When it drops back in, it gives you red light, and so that's how you get the red nebulosity.
Right. Okay, perfect. Thank you.
Oh, you're welcome.
Okay, so let's see. We talked about Antares. Did you want to talk about M4 since we're...
Yes, let's talk about M4 because
Okay.
it's real easy. Once you find Antares, you can find M4 quite easily.
Yes.
Because it's got that. It's just to the west and down to the south just a little bit from Antares. And so it's a pretty, once it gets dark out, it's pretty easy to pull in. Plus, it's the nearest globular cluster out there. And so, it's nice to have something in close. It's only 5,600 light years away. So it's pretty close.
Mm-hmm.
In fact, you should be able to see it there. I think I see a fuzzy spot just over from Antares.
Give it a minute. I think you've got another delay on your end. I don't know if it's internet speed or what, but I'm keeping up with you. It'll show in just a minute.
Oh, okay. Yeah, because right now I'm seeing an image of the whole constellation.
Okay, let me see if I can get
And
another
there
picture.
it is.
You see it?
Yeah, yeah. It's a nice globular cluster. It's easy to find since it's just over from Antares. It's a real easy one.
Mm-hmm.
And it's our nearest one. At, being only 5,600 light years away, that's, pretty close overall.
It is. Now, this is
And
something you
did
can
you-
see with binoculars?
Oh, definitely. Yeah, yeah. It's an easy binocular object.
Okay. Awesome.
It's magnitude 5.9. I'm sure there's some eagle eye people out there that have probably seen it naked eye before.
I'm sure it would not be me. Well,
Yeah, my eyes aren't that good, but there are a few people with really good eyes out there. But the average person, just get a pair of binoculars, 750s, 1050s, and that'll work out pretty good.
okay, great. So tell me about the
Well,
butterfly. Oh, I'm sorry. Go ahead.
Did you want to talk about the difference between globular and open clusters?
Oh, yes. Thank you for reminding me. What's the difference?
I mean, there's a big difference. Is globular clusters are really old, 10, 11 billion years old. They're also very rich for the most part. There's, 100,000 stars on the average in them or more. Where open clusters are usually in the disk of our galaxy or nearby. They're formed in H2 regions, and like the Orion Nebula or the Pleiades is an open cluster. Eventually they get tore apart, so it's hard to find an open cluster that's 1 billion years old.
Perfect. Yeah, I've got a picture here from Astronomy magazine about an open cluster here and also a globular cluster, NGC 104.
Yeah, big difference between the two, and 104 is like the showpiece.
It is.
That's 47 Tucana. That's kind of like cheating,
I thought you'd appreciate that.
Yeah, that one in my 20-inch just really blows my socks off. It's a awesome object to see.
Yes.
But you got to be down in the southern hemisphere because it's right next to the Small Magellanic Cloud.
Yes, I wanted to bring that up because we have a number of people from Australia that are on tonight, so that was just for them.
Oh, cool.
Okay, so let's get back.
I was observing from Western Australia and had a great time down there.
That's right. Kent actually brought his telescope down to Australia. How many times did you go?
The 8-inch I brought once, and the 20-inch I air freighted down there 3 times. So I've made 4 trips to Western Australia.
Wow, that's awesome. Okay, so where were we? We were talking about, how about the butterfly cluster? Is that a good one to bring up?
Oh, okay. Actually, next in line really should be M7.
Oh, M7.
Remember the pointers on the Scorpion? They pointed M7.
Yes.
M7's a cool open cluster. Beautiful binocular object. It was found a long, long time ago. Ptolemy was the first guy to catalog it in, I think, 130 A.D. He put in his catalog of fuzzy objects. You look at it, you can actually see it naked eye. It does look kind of fuzzy, but in binoculars, M7 is really nice, and the stinger of the Scorpion kind of points at it roughly. But it's really a nice binocular object, not so great in a telescope because the field is limited, usually through the eyepiece of a telescope. But for 750s, 1050s, it looks really nice. And that's an easy one. And I guess next we can go to M6, which is the butterfly cluster.
Okay, which is right next door. Yep, I've got it highlighted here.
Cool, yeah, you've got the brackets on it. And it's about, M7 is about 980 light years away.
M7 or M6?
M7.
M7, okay. So Ptolemy's cluster.
Yeah, M6 is up a bit further and a little bit west from M7. It's also in Scorpius. It's fainter. It's magnitude 4.2, where M7 is magnitude 3.3. But it's a nice binocular object. I don't think it's a naked eye object. But it's just a neat little open cluster, and its real claim to fame is it's pretty close to the center of the galaxy.
Yeah.
The actual center of the galaxy is about 3 degrees north and a little bit to the east.
That's awesome.
And unfortunately, there's nothing cool marking that.
No, there isn't.
There's so much gas and dust and junk in the way that it takes like infrared or radio waves to actually look towards the center of our galaxy.
Yeah, it does.
But
There's just so much stuff in the way.
But if you're looking at M6, you're pretty close to the center of the galaxy.
Mm-hmm.
It's just a little bit further north and a little bit east.
Perfect. Did you want to talk about the pipe?
Yeah, the pipe is cool. We didn't get around to it last month. It's actually above the back of Scorpius, and it's actually kind of in the feet of Ophiuchus, who we talked about last month. But it's a really nice binocular object. It looks like a black pipe in the sky. It's actually a dark nebula. Most of the darkness is caused by big clouds of carbon dust. Regular giant stars in their evolution will produce a lot of carbon, and they puff it out like smoke, and then it drifts around and clumps together and forms dark nebula, and eventually probably will form some brand new stars in that area. But the pipe is real easy to see. It's got the stem, and then it's got the bowl is to the east. The stem is to the west. You can kind of see there's like an outline of stars along in there, right along like the stem of the pipe there. And I get the feeling that the dust is blocking other stars that are, behind the dust cloud. And I was trying to find a distance this afternoon, but I couldn't find a good distance to the pipe. It's also called Barnard 78, I believe.
Yes, that's right.
And you can see a bunch of dark nebula around that general area. There is a lot of dusty nebulas around that central area there.
Yeah, it doesn't look like much on Stellarium. Go ahead.
Oh, it's just such a cool object to sit. I remember many a time I'd sit back at Navajo Flats, and I could easily see the Pipe Nebula with my 750 binoculars. Some people have seen it naked eye.
Wow.
So if you got a really good dark area and they got good eyes, they can pull it out naked eye.
Wow, that's amazing.
Yeah. For me, that never happened. But the binoculars really help.
They do. Kent, we got a number of questions that have been coming in. Apparently, Brian's been flooded. So before we hit the next constellation, do you want to take a few?
Sure.
Okay, great. For the folks, I think I neglected to say how you can ask questions. You can use the chat box, or you can use that little thing underneath me. It says questions. You can actually text Brian at that number. Don't call him, just text him your question. Or you can email it to questions@centralcoastastronomy.org. So folks that are watching us on a television, like a smart TV or something, you can those are options available for you as well. Okay, Kent, here we go. Hello, thank you so much for tonight. They are wondering, I don't have a name with this person, will I be able to see the rings of Saturn using 8x40 binoculars? And do I need a tripod?
Tell you the truth, with my eyes, I can't see the rings in 8x50s. So you probably won't see them in 8x40s. You might notice there may be a little bit, if your eyes are really good, you may be able to see a little bit of, that it's like a yellow star, but it'll have a little bit fatter in one direction. So you might be able to pick that up, but I don't think those are good enough to actually see rings.
Yes. Okay, great. And Laura is asking, how do all the parts of the sky scanned by... so how basically the question is, how do things like Stellarium get their pictures, get their images? And you actually know a little bit about this, don't you?
You mean, okay, yeah, the online atlas, those guys must have enormous, it's going to take a lot of programming to actually put in the pictures and everything to blow them up. There's got to be a lot of files sitting back there just waiting for deep sky objects. So, it's some really smart people with programming that actually set up something like that.
Yeah, and these are real pictures. These are not artists' images and paintings. These are real photographs that have been taken by scientists.
Yeah, actually, if you go on Google and put in like a Messier, go, M7 or M8, there'll be a ton of pictures that amateurs have posted out there that'll pop up for the various deep sky objects. So I'm sure the guys that put together these programs go and look at these various pictures and get permission from the photographers or the imagers. I think everyone's an imager now since it's all digital.
Yes. Okay, great. Thank you. 2 more quick questions. Let's see. How do stars get their name? This is from Leah.
Oh, the brighter stars, it goes way back. It turns out a lot of the stars have Greek names, and there's really old names that go back to the Babylonians and things like that. Everyone had different constellations and different names for the stars. What we deal with today are mainly Greek constellations that the Arabic civilization at that time preserved the Greek astronomy works. And a lot of the stars have Arabic names to them, and we just carried them on. I think when they stole the libraries in southern Spain and translated them from Arabic into Latin, they just carried on the best pronunciation they could with the Greek language. So we got some really weird names for stars like Betelgeuse, the armpit of the giant, or Deb Nola, the tail of the lion. There's a whole mess of Arabic names. So I bet you most of the bright stars, or ones you can see naked eye, have multiple names.
Awesome. Thank you. Let's see. We have a number of people asking, can you please finish the Scorpius myth before we move on to the next constellation? Do you want to tell us a little bit about the mythology?
Oh, pardon? I'm sorry.
That's okay. The mythology of Scorpius. Remember I cut you off there?
Mythology, sure.
Yeah.
Sure. In fact, yeah, that's something I'm glad they brought it up.
Yes. I wasn't going to let you...
I almost forgot about it.
It's okay. I wasn't going to let you forget, but I'm glad people are on it too. Go for it.
Yeah, I mean, there's all sorts of legends going way back. I remember seeing I think it was a carving of the zodiac out of Egypt that goes back, 5,000, 6,000 years. I mean, it goes all the way back to before the pyramids. And, they still had the scorpion there. So there's, almost every society had their legends. But the one for the Greeks has a legend that starts with Orion, which was also considered, Achilles at times is used rather than Orion. But he did some bragging about what a great hunter he was, and eventually got under the skin of the gods. So they sent a scorpion to sting him in the heel. And, of course, he died. And, usually after the gods kill someone, they feel bad about it. So they put Orion up in the heavens, but also they put the scorpion in the heavens. But they put them on opposite sides of the sky. When the scorpion rises, Orion's already set. When the scorpion sets, then Orion comes up. So they never meet, always being opposite sides of the sky. And the interesting thing is there's one other Class M supergiant. It turns out it's Betelgeuse in the shoulder of Orion. And so Scorpius and Orion have the two M-class supergiants.
Perfect. Awesome. Thank you. Okay, so let me get back onto the other part of the world. I was showing Orion while you were talking. Okay.
Oh, okay.
Okay, so we have Scorpius. And what else is great to look at tonight?
You got to hit Sagittarius.
Yes. And what does Sagittarius look like to most people? Whoops.
It looks like a teapot.
It does.
Do you remember how we talked about the teapot with the handle, the body, and the spout?
Mm-hmm. Yep, that's
that
it
one
right
would
there.
be good. You know, and the interesting thing, if you look at the spout, the Milky Way goes right up through it, and that's the steam coming out of your teapot. So it's, I definitely have a delay with the graphics.
You do. I'm sorry. We tried to fix that, but apparently we didn't do a good job.
But,
that's okay. Here,
we talked about the teapot. So the first thing you notice is the handle. Those 4 stars that make up the handle of the teapot, and then you've got the stars that make up the spout, and in between is kind of like the body, with one star kind of up above, being like the top of the teapot or the the cover of the teapot. So it does kind of look like a little teapot there.
Yes, it does.
In truth, it's a centaur with a bow and arrow, and it's referred to as the archer in all sorts of mythology. And but the teapot's easy to show people. And you can also show them how the Milky Way is kind of like the steam coming out of the teapot. Mm-hmm. And that's the top of the handle, or not the handle, the lid. There, that one star you were circling. So, a lot of times people use the teapot.
Perfect.
And I guess before I forget about it, I should talk about the mythology of the archer.
Yes, please do.
Being that there's, again, a lot of different myths and things like that, but one of the Western myths ties in with another centaur. There's 2 centaurs in the sky. There's a constellation that's way down south called Centaurus, and then we've got the centaur with his bow and arrow in Sagittarius. And the legends go that Centaurus was a teacher of mankind. The god's beloved, his name was Charon, and he taught like Ophiuchus, which we covered last month. He taught him how to be the best doctor in the world. Mm-hmm. He also taught humans about astronomy and the constellations. So he put Sagittarius up there to have Centaur in the constellations. And later on, he got put up there because Hercules killed him by accident. Hercules was really good for killing everybody in sight, and he accidentally killed poor old Chiron with a poison arrow. And so that's the old Greek myth, and everyone felt so bad they put Chiron up in the stars, but it's way down south, so it's for the folks in Australia or South Africa or South America. And that's the legend there.
Perfect. Now, we have a quick question that's coming in about Sagittarius, asking what is the tight circle of stars below the teapot? That's from Richard. I think he means... Go ahead.
There is a group of stars which is... you've got the Corona Borealis, and this is Corona Australis, the Southern Crown. I don't know if that showed up on the graphics or not, but that's a circle. Actually, it's partial circle, but it's more of they call it the Southern Crown, and it's in lower Sagittarius. It's like the next constellation down. In fact, there it is, Corona Australis. I can see that curved arc, and it's just below the body of the teapot. And so that's pretty far south, and that's for another discussion. But that's another constellation down there.
Okay, great. Okay, so tell us, what's so great about Sagittarius? Why should we bother?
Okay, there is so much junk. Yeah, I mean, there's all sorts of deep sky objects in both Scorpius and Sagittarius. We're leaving out the telescopic ones for the most part and going for the ones you can be seen with binoculars. Mm-hmm. And on your handout, you've got M55, which is a globular cluster, visible binoculars. It's kind of to the east in Sagittarius, and it's a nice globular cluster. I can pick it up quite easily in my 750s when I'm sitting out at Navajo Flats. And it's just, average run-of-the-mill globular, but it shows up good in binoculars.
Nice. Perfect. Okay,
and
great.
Let's see, I think it's 19,300 light years away, so it's out there a ways.
Yes.
But because it's kind of all by itself out there, mm-hmm. It kind of makes it easier for you to pick it up in binoculars. It's away from the Milky Way. It's kind of a sparse region, so it stands out easier to see.
Nice. Okay, so after you found M55, where should we go now?
Okay, the next one's a real fun object called M22. That's kind of near actually a little bit east of the top of the lid for the teapot. And it's interesting because M22 is kind of bracketed by little groups of stars on either side. Mm-hmm. And M22 is also a quite bright globular cluster. One thing I like to do on star parties is I try and get M22 in my telescope while it's still fairly light out, when the stars are just starting to pop in. And when you do that, you only see the red giant. So it actually looks like little open cluster of red stars. And you can watch them kind of fade away as the whole background comes in eventually, and you can't even pick them up after a while. But for a narrow window of time, you see about probably a couple dozen red stars. It does look like a little open cluster. And so I've only been able to do that using the 20-inch with M22. And I think it's because I read somewhere there's a dust cloud mm-hmm. between us and M22, so that probably reddens those giants even more. Oh, also for distance, that one's it's a nearby one, relatively nearby, at 10,400 light years.
Nice. Okay, so we've jumped around to what's next in this area that you would look at?
Oh, let's see. Next is a fun object that's actually naked eye called the Lagoon Nebula, mm-hmm. or Messier 8. You have to kind of slide west from M22 to pick it up, but I can be out in Navajo Flats where it's good and dark, and I can actually see an elongated object, and that's actually the Lagoon Nebula. And the cool thing about Lagoon Nebula is there's actually 3 objects there. So it's kind of like 3 for 1.
Tell us about the 3 objects.
You've got an open cluster. It actually has an NGC number. It's 6523. Very young open cluster. And then there's just over from it, there's a dark lane. It's a skinny, long, doesn't have a Barnard number to it. Probably because they included it in M8. Mm-hmm. But it's some people say it's the entrance to the lagoon. You got the dark lane, and then just beyond that, you have a bright H2 region where stars are being born, and there's actually what they call the hourglass, a really bright area that looks into the nebula. The Hubble's taken some pictures of the hourglass region, and it's really bizarre looking, like there's kind of like tornadoes or something in there. And you can only resolve it with like using the Hubble to see that detail. But Lagoon is a real easy binocular object. You can see it naked eye. It kind of looks like a elongated section of the Milky Way. naked eye. And surrounding the cluster and the dark lane and the bright H2 region is a fainter H2 region. Actually, it's got O3 in it because you can pick it up with an O3 filter and light up that whole area. If I've got a 2-inch O3 filter, I'll screw into the big eyepiece, and you can see nebulosity all around that area. So it's really a beautiful object.
Wow, that's awesome. Okay, let's give everybody a quiz here. I'm actually going to move the planetarium a little bit, shake it up, and there are no lines connecting any of the dots. So quick, can you find Scorpius? Okay, you want to look south. Here's my south and my southeast. Can you find it? Do you see that red star? Okay, you see that red star? Good. That's Antares. Good. Can you find Scorpius? Do you see it? Good. And now, where is the teapot? Can you find it? There are no connect the dot little lines in here because this is what it's really going to look like tonight. Actually, I should turn off the Milky Way, and that's really what it'll look like. Here, we'll turn on the atmosphere a little bit and kind of dim things. There we go. Now, if you live in a city, this is more of what it's going to look like. Maybe a little on a very good night. Okay. Do you see the teapot there? Did you find it? Here, if I turn it on, does that help? Good job. Here, I'm going to turn it off. Practice again. Do you see it? Okay, now where's the Lagoon Nebula? Can you see it? You can actually see it on the program. Did you look up in this region? Good. You guys are doing so good. Okay. All right. Kent, what else should we look? Oh, did we look at M24?
I'm thinking M24 next because, you know, it's not like your typical open cluster or globular. It's just a bright section in the Milky Way. And the reason it's bright is there's no dust blocking it, or very little dust blocking it. So you're looking deep into our galaxy, or deep into the Milky Way. So that's why it's so bright. It's just this little bright section. It's not little. It's actually pretty good size. But you can definitely see it in your binoculars. And it stands out because there's very little dust there.
Awesome. Yeah, I've got it right here. And so this is where you want to look at it right above the handle of the, or not the handle, I'm calling it the handle too.
Yeah, you see, you know, it's actually kind of a hole through the dust into the deeper portions of the galaxy there.
It's so cool.
So you can see how it stands out for being bright.
Yes. Nice.
And so, plus you can see, you know, this is the telescopic view will show you a couple little dark nebula that are superimposed on M24. And also your handout was saying you get about 1,000 stars in your binoculars. So I know there's a lot there.
That's a lot. I mean, you got to be a kid in order to see those.
Yeah. Kids have good eyes.
They have really good eyes. Exactly.
But, you know, the thing to do is think about it's kind of like a hole.
Yeah.
You know, going deeper into the brighter, you know, bright section. There's a, you know, if you can remove all that gas and dust, that whole area would look so bright it wouldn't be funny.
So tell me, what else is in this area? I know there's a million different things, but what other couple ones can we look at with binoculars?
Neat binocular objects is on the western side of M24 is a nice little open cluster called M23. And it's about 2,100 light years away. And, you know, quite visible in binoculars. You know, usually I use M24 as kind of find M24 and then drift westward. That's it, westward. You come across the little open cluster M23.
Now this is above Lagoon, right?
Oh, pardon?
This one, it will be above the Lagoon Nebula if people are looking for it.
Actually, it's you go to M24 and it's west of M24.
Okay, perfect.
There you got it.
Yeah. Okay, great.
Yeah, that's a nice, you know, another nice open cluster. And then kind of just opposite on the other side of M24, on the eastern side, there's a really nice open cluster called M25. And it's about 2,000 light years away. The thing about M25 in the finder scope or binoculars, it has almost kind of like a spiral pattern. It's a really what should I say, the stars have a lot of variation in brightness, and it seems to make kind of like a curved spiral, if I remember correctly, when you're looking at it in binoculars.
Mm-hmm.
So it's kind of a nice, another, bright open cluster.
Nice. Okay, great. And did we talk about M17?
We haven't talked about the Swan Nebula yet.
Okay.
That's like the last one on our list, I think.
I think so. I think you hit all of them already. There's so many things.
The Swan is one of the brightest, Messier objects for a H2 region. It's really where stars are being born. It stands out with an O3 filter, and with no filter, you can actually. It's kind of funny in my 8-inch. It looks like an upside-down wooden duck or a decoy duck. It has an elongated body and then a little curve for the neck, but everything's reversed in my C8, so it's upside down. Or I guess, up and down are okay. Left and right are reversed. But anyhow, it looks like an upside-down wooden duck is what I've called it for years. And it's also called the Omega Nebula. But it looks more like a swan than it does, like the letter omega.
Mm-hmm.
And that area is loaded with young stars. Infrared, it lights up. So it's a definite star factory there, or a big star birth area. So, and it's, really nice and bright.
Yeah.
In fact, I think, what was my Mag 6 you had down there? So. Yeah, it's definitely easy binocular object. Some people have seen it naked eye. Those folks with really good eyes that live in Hawaii or someplace, where the thing's like straight overhead.
Now, we didn't even talk about Mag 6, Mag 3, Mag 7. With binoculars, what's a typical range, would you think, that people can expect to see? I know it's.
We talked about that one time. I kind of forgot. But I think if you're getting around Mag 9 to Mag 10, you're starting to get down there. You're running 750s, 1050s. But I've never gone out and tried to see how faint an object I could pull in with a pair of binoculars.
But if you say something is magnitude like 6, could I expect to see it my binoculars?
Oh, yeah, easy.
Okay.
In fact, Mag 6 under dark skies and overhead, you'd probably be able to see it with your eyes. So
without binoculars.
Mag 6 will be easy. And the objects that we pointed out tonight, you should be able to see all of them real easily with binoculars.
Mm-hmm. Nice. Okay, great.
Oh, one other thing that we kind of didn't mention was, we mentioned the center of the galaxy, but also the bulge of the galaxy is right above Sagittarius and Scorpius. And you can actually see the dark lane that runs this time of year. You can see it really good. Is the dark lane kind of runs in the middle towards Cygnus. So when you look at the Milky Way, you see a gap. And they used to call it the Great Rift because they thought it was a hole. But it isn't. It's really our dust lane in our galaxy. So that's, can be easily seen this time of year when the Milky Way gets up nicely.
Mm-hmm. Let's see, you mentioned Cygnus. Let me kind of point out where that is here. Cygnus is all the way up here.
Yeah, Cygnus is up a ways.
Yeah, that's okay. It's almost overhead.
You can see the bulge of the galaxy. Actually, Antares is kind of sitting on top of the bulge in the diagram there.
Yeah. Now, we had a couple of questions about the Swan Nebula. One of them was, what kind of nebula is the Swan Nebula?
What sort of nebula?
Yeah, the question is, what kind of nebula?
Oh, for the dark nebulas?
No, for the Swan Nebula, for M17.
Oh, the Swan is an H2 region. Most of the red ones, like the Orion Nebula, the Swan that we're looking at, and like last month the Eagle. They're all H2 regions. Also they fall under the Bright Nebula category, but then they break that down into, there's also Blue Nebula that are reflection nebula from blue stars. And there's actually a whole mess of different types of nebulas. You got the bright ones, you got the dark ones, you got the Planetary Nebula ones, you got the supernova remnants. It just goes on and on.
It does. And you happen to know a little about that, don't you?
The Planetary Nebula, those are the ones I went crazy after. I've probably seen about, probably close to 700, maybe 800 planetary nebulas throughout the entire sky.
Wow.
Yeah, that's taken like 20 years to do that. So, but that's why I went down to Australia to look at the ones they had down there. And also I was able to see planetary nebula in the large and small Magellanic Clouds, which I think the large one's like 160,000 light years away.
Wow.
And the small Magellanic Cloud is 180,000 light years away. So those are way, way out there.
Yeah. Now, a planetary nebula, do you want to tell us about that? We're getting questions about why planets are involved.
Actually, it's kind of funny on the name Planetary Nebula. It's like a misnomer. Has nothing to do with planets. When William Herschel was looking at these nebula, he noticed that they were disc-shaped and they had a pretty sharp edge to them. They kind of looked like how a planet looked to him in his telescopes. But they didn't move, so they had to be some sort of nebula. So he basically called them planetary nebula based on their geometry. Being a round disk, somewhere elliptical, but they had like a sharp edge, kind of like a planet would. But they just sat there in the same place. And so we get to blame William Herschel. He's probably the best deep sky observer. He found like 2,500 deep sky objects. So he really beat out Messier. He's the guy right after Messier. But he gave the name.
Yes. We had a number of people ask what the M means. Do you want to talk about him?
Oh, okay. Messier objects. Charles Messier was in the 1700s. He was a comet hunter. And he made up a nuisance list. There were these fuzzy objects, because he had really, small telescopes. And he'd come across these fuzzy objects, and he'd think it was a comet, but it wouldn't move. It just sat there. And like the first one in this list is Messier 1, which is the Crab Nebula, which is a supernova remnant. So he just, kept making his list and printing it. I think he did like 3 lists over his lifetime that he printed. And right now we have about 110 objects that we call Messier objects, but they're the nuisance objects. He really didn't care for them. He was hunting down comets. That was his important thing. But now everyone remembers him for his Messier objects. No one knows his comets.
I know,
so
everybody knows. It's so funny.
It turns out it's all the neat stuff, the neat open clusters, the neat globulars, the neat H2 regions, a lot of neat stuff, in its lists. And so when you're an amateur and you get a telescope, you start going after Messier objects, because 110 objects, that's not too bad. And it's mainly for stuff in the northern hemisphere. They really didn't have a Messier for the southern hemisphere. Although there were people that went down south and found a few objects here and there. It turns out William Herschel's son, John Herschel, hauled a 20-inch telescope down to the Cape of Good Hope, and I think he found another almost 2,000 deep sky objects. So he really did a good job.
Yeah.
And they put it all together, his father's stuff and his stuff, into what they call the general catalog. And then later on, they had to revise it, so they came out with the new general catalog, or NGC. And I don't know if you've noticed, but a lot of these deep sky objects, if they don't have a Messier number, they'll have an NGC object. We're still using the NGC catalog, even though they put it together in 1888. And so it's still like the catalog for, really neat deep sky stuff. But there's like 7,000 objects, so, most people won't live long enough to see all of those.
No, not at all. Awesome. So there's a couple other questions that have come up that have more to do with telescopes. And we have another question. What is a Caldwell catalog?
Oh, Caldwell objects?
Yes.
Oh, what it is, there was a British amateur astronomer, what was his name? But it turned out he wanted to make a list of objects beyond the Messier list, and so he used like his middle name, which was Caldwell. And so he just came up with these Caldwell objects. It turned out most of them were bright NGC objects that everyone knew by the NGC numbers anyhow. Some people love the Caldwell list, some people hate the Caldwell list. But there are books out of Caldwell objects. And I just can't remember the guy. He liked to wear a monocle, believe it or not.
Patrick Moore. Is that who you were thinking of?
Patrick Moore, that's it. Yeah, yes. Patrick Moore. He did like a radio show for years on astronomy in England. And he did all sorts of books, that sort of thing. But yeah, my personal opinion is it just gives you another number to remember.
Yeah.
And I don't even try and remember the Caldwell numbers. I try and remember the NGC numbers or the names.
Right. There's already so many numbers to remember.
I mean, the thing is, anyone can make up a list and put their name on it. You could have the Aurora list.
Yes.
But the problem is, if no one remembers it, it all just falls into the dustbin of history and it's gone.
Yeah, especially when it's after the fact. I think Messier, he was one of the first to be doing that. And he was racing other people.
Oh yeah. I mean, Messier really didn't care about his nuisance list, other than it told other people there's a fuzzy thing there that looks like a comet isn't, and it won't move. So don't waste any time on it.
Right. It was his list of what not to look at.
Yeah, that's really, honestly, that's what it
was.
It was a list of those, if there's a fuzzy thing there and you'll swear it's a comet, but you'll spend hours watching it and it won't go anywhere.
That's true. So there's a couple of other questions. Oh, I should just mention there's a few people asking about the marathon. So astronomers run marathons, they're in really good shape, but it's all done by the telescope. So there's 2 weekends, I think. You guys can correct me. I think it's March is the best one, but there's also one for October in the Northern Hemisphere. Brian's nodding his head, where you can actually see all 110 if you start right at sunset, and you should be able to see. March is the better one, especially for weather. Oh, look at you. Wait, let me hang on, you're going on. Hang on. So yes, go ahead. That is the book.
Yes, this is the Messier Marathon handbook or field guide, and it's useful anytime during the year, but of course we really want it during those times. And what's amazing is you're starting right as the sun is going down, and this book has charts that shows you gradients of how bright the sky will be, and you're working all night until the sun, just before the sun is coming up. And it's an excellent set of charts, even just to find all the Messier objects to use as you're learning the night sky. And it's really mostly based around using the Telrad, which gives you those 3 concentric circles projected on the sky, but he also has finder scope diagrams and sketches, so you have an idea of what to look for.
Awesome.
So I've got that book.
You have that book.
You're holding it there.
I do too.
Yeah, and I had the fortunate privilege of learning from Harvard Pennington when he was developing the manuscript. So this one's near and dear to me. Yeah, he's with Pomona Valley Amateur Astronomers in Southern California. So I'll post a link to this book in the chat.
Oh, that's awesome. Thank you, Brian. Thank you. And don't go away. You're coming back on in a minute here.
I'm still here.
Yes. So Brian has been tirelessly answering everybody's questions. So give him a big hand, everybody. Yay! Kent, there's a few more questions I was hoping you would answer. Are you up for a couple more?
Sure.
Okay, great. Okay, so the first question is, people are wondering, can I leave my telescope out, or do I always have to pack it up? You know, I want it out and available so I can use it on the back, you know, when I feel like it, but is it bad for the telescope? What's your feeling on that?
You know, I missed kind of it's something about a telescope and using something.
Oh, okay. Let me talk a little more clear. Sorry. The way we have Kent patched through, I don't know if you heard this, he's on a rotary phone. And so we've had to do a little bit of duct tape and baling wire to get him piped in to our presentation tonight. So sometimes he can't hear as clearly. So Kent, the question is, can I keep my telescope up all the time? Or is that bad for the telescope? Do I need to keep it in a case? Or can I just keep it out in the open?
You know, there's two things. As long as you aren't worried about it getting stolen, and you have a really good cover that goes over it to protect it from the wind, you know, and rain or whatever, you can keep it outside, you know, but you want to have the base secured so that a gust of wind doesn't knock the whole thing over.
Okay, what if you keep it up in your house? What about that? But just not in a case.
Then there's no problem. I mean, you want to keep the dust covers on everything, because otherwise you're going to be having to wipe dust off of, you know, the corrector plate or lenses. It's always good to have a cover over all the optics to keep, you know, dust will sneak in there no matter what. Mm-hmm. And so, yeah, it's fine to keep it on its mount inside the house. And, you know, it all depends on the environment inside the house also. If you've got kids that are fighting and running around and stuff like that you would think will trip over the tripod and crash the whole thing, then you might want to put it away. But otherwise, if, you know, there's nothing that'll knock it over like a big dog or something like that, there's no problem with keeping it upright and on the mount.
Okay, great. Perfect. And another question is... what kind of telescope do you recommend for, oh, you know what? I can actually handle this one because Kent, we did our homework in advance. So if you're looking for telescope, binocular, or beginning astronomy, taking photographs of things, equipment, look on your last page of your handout. We've actually put this together with links directly to websites. And so you can click on those. You can click on the original document before you print it out. So this is for you. So for kids, for grown-ups, binoculars, telescopes, and all of that. So your recommendations are already printed out for you. So yay! So don't forget to look at the last page. Other questions? Let's see. Other questions? Brian, let me bring you on. Do you have any other questions for Kent before we thank him and close out with more talk about the comet?
Oh, thanks, Kent. It's a wonderful presentation as always. I did just have one more question, but Aurora, I'm wondering if that might be one for you, if you're aware of a good stargazing app for kids that could help get them started in looking at the night sky. I recommended,
yeah, go ahead.
You know, of course, Stellarium for the program, but then do you know of an app?
That's a really good question. I personally use Sky Safari. I have an Android phone. When I was going through it, I downloaded like 10 of them, and I kept the one that I liked best. That's what
I use as well, because then it can, when you get the Pro, then you can lock it in with telescopes.
Yes.
Too.
Yes, and one thing that I would be aware of if you're working with kids is to make sure it's not too, how do you say this politely? Not too dumbed down and too like, I don't know how to politely say this, but like, and make sure it's not, it doesn't have like purple dinosaurs or something on it. You want it to be real at what they're learning. So like a real scientific instrument, so they learn that it's a tool and it's not a toy. And they also learn how to use it, especially at an early age. My daughter can tell you exactly what planets are up tonight just using a wall chart that we have that astronomers use because we've taught her how to do that. So like I wouldn't give my kid a measuring tape with like, you know, hearts and flowers all over it. I would make sure the measuring tape could measure something. Does that make sense? So that would be my recommendation. Just give kids and give them the instruction that they need with it. It's, again, not a toy. It's something that you would want to use. There is overkill, right? You don't want the one that's too difficult and you just give up on it. But I like Sky Safari because you can click on tonight's best and it'll give you a tour and you put it up and then it'll say, okay, now make it go more this way. Okay, make it go a little this way. Okay, there it is right there. And then you take it off and you look in that same section of the sky and you put your binoculars up to your eyeballs or naked eye, and you'll be able to see what the app is telling you. So, how's that?
Well, hey, Aurora.
Yes.
This is Ken. I got a question for you.
Oh, yes.
You have the HA Ray. You have the HA Ray book.
I do.
Around there?
I do. Look at this.
You know, I was thinking maybe you can show folks how simple that book looks.
Okay.
It
yes.
looks like it's made for like second graders, but it's really the easiest way to learn the constellations that I've come across.
So tell me, who is this author? Is this anybody people would know? Who is the author of The Stars, Kent? Who is that guy?
H.A. Ray.
Yes.
Is the author of The Stars, A New Way to See Them.
And what else did he write?
I mean, that looks like he did the Curious George books, all the Curious George books. That book was produced in 1952, and, you know, I still pull the thing down and use it at times.
So this is a good resource, especially if you've got kids and you want to start learning the constellations. There's nothing that beats an old book because you can write your notes in it. You can dog ear pages. Sorry, English teachers, I do that. And you can really make this your own. And as Kent said, 50 years later, you could still pull it out. Try that with an app. But you can definitely do this.
And the thing is, it's still in print after all these years.
Yeah, that tells you something, doesn't it?
Yeah, the thing I like also is it has extra beyond the blue area there. So it has lots of overlay from the main constellations.
Yeah, definitely. Great. All right, Kent. Well, I thank you so much for being with us. Everybody don't leave yet. I've got a couple of quick announcements for you for the next stargazing, and we're going to talk a little bit more about the comet, answering all the questions that have been coming in. But first, we're going to say thank you to Kent. Go ahead and take your typing fingers out and drop Kent a note. We actually copy and paste all of these comments and give them to him. So if you enjoyed tonight's presentation, just let him know. Just drop him a note. Put it in the comment box right now. Tell him what you enjoyed most, what you really... anything that you really appreciated about tonight's presentation. So while you're doing that, Kent, I just want to extend my personal thank you to you after so many years of knowing you and doing stargazing together with you. It's always such a pleasure. And thank you for sharing your knowledge with everybody.
Well, thank you, Aurora, and thanks for doing all the hard work. I just sit here, I'm like a disembodied voice.
I know.
You're doing all the hard work.
Oh, it's really no problem. It's my pleasure. You're the one who did the hard work all those years with the telescope and lifting and shipping. So now it's my turn. So I'm totally happy to do that. So.
Okay, thank you very much.
You're
I'll
welcome.
go now.
Thank you, Kent.
See
Have
you
a
later.
good night.
Thank you. Bye.
Bye-bye. All right, Brian.
All right.
So now we get to talk about the comet. Yay! Now, for those of you who just kind of, I don't even have our slide up. I'm sorry, our overlay up. There you go. This is the Central Coast Astronomical Society. We're closing things out really quick. We're going to answer a ton of questions that have come in about the comet, and we'll try to do it really, really briefly. And yes, when we're done tonight, like even on the West Coast now in California, it's sunset. This is the perfect time to go see the comet. So we're going to show you how to do that and now. And also, I don't know if you knew this, but Kent was just sitting there in a chair talking to us. This is one of the first times he actually has seen what it looks like when he does a presentation. All of this is just from his head. And yes, we make a handout in advance now because otherwise he's like all over the place because he's so excited about so many things to talk about. So he's just amazing, amazing light in the sky. Okay, so let's see. Brian, do you want to take it away and answer some questions about the comet?
Yes.
And then we'll announce our next one. Okay, go ahead.
Yeah, you betcha. So yes, we had multiple questions come in about the comet. So one of them was, can we see the comet more than one night? The answer to that one is yes, indeed. You could start tonight if the sun hasn't already set and it's between like 9:30 and 10:30 at night. But the idea is the comet is now moving away from the sun, but still coming somewhat closer to us. But don't worry, it'll still be way off. But so every night we can look for the comet, but the thing is, it's most likely going to be getting more and more faint every night. So the farther away it gets each night, the more magnification we'll need to use to see it. Right now, in many areas, it's naked eye, no magnification needed. Then you'll need binoculars and then a stronger telescope. But you can see it. So definitely go and look every night. I've posted links in the chat that'll give you access to a chart so you can look and see where it will be over the coming nights. Shall I continue, Aurora?
Yes. Do you want to show them your picture in case they missed it? Because
sure.
we kind of started early.
Yeah, you betcha.
Yeah.
So I'm bringing up the share controls here so I can do that.
Oh, take your time.
And so I will share that, and then I will bring up the picture. So this is a picture of the comet that I took on July 11th in the morning. It's about
We're just seeing
4:30 in the morning.
YouTube right now.
Say again?
We're just seeing you on YouTube.
Oh, I'm sharing. Whoops, I shared the wrong screen.
That's
that
okay.
Doesn't help us. And look at me again.
Yes. Okay, now I see you.
All right. I'll just share the actual program itself.
There you go. Perfect.
All right, so this is not me. This is the comet. This is taken about 4:30 in the morning, and this was back when it was more of a morning object. Now it is more favorable for the evening. Thank goodness. No more of those early mornings. And what you want to do is look to the northwest, just after sunset, and it'll be between the Big Dipper and the horizon right now, but it'll be moving up from our perspective towards the left of the Big Dipper. But again, there's charts online that can share that with you and help you see more.
Nice. Perfect.
All right.
So do you want to show people, do you want me to show them on Stellarium or do you want to?
Oh, I'll go ahead.
Yeah, great.
Okay. And bringing up the share again.
So where do you look? You go outside and boy, you don't see it. So what direction should we be looking in?
Yes. All right. So what you want to do, let's turn this around to the northwest. And then let me make sure what time I had it paused. Let's make sure it stayed paused on the time. So let's actually advance it up. So this would be 9:30 at night. And hey, does anyone recognize a familiar constellation right around this area? Let me turn on some lines. So this would be the constellation Ursa Major, and we're looking for the scoop part. As you get to these other stars down towards the head of the bear, they're a little more faint, especially when they're low in the horizon. Let me turn on the comet for you. So tonight, right now, for us here in central Southern California, this is where we'll see the comet, down below the horizon and the bottom two stars of the Big Dipper. But then I'll go ahead and show you, as we advance, this is for the 18th tonight. If we go out and look tomorrow, then this is where it will be on the 19th and then the 20th. Now it's going to be the closest to Earth, this comet that is, in its orbit as it's heading out of the solar system between July 22nd and 23rd, depending on your time zone. So this is where we would look for it on that date. Notice that here's the bottom two stars of the Big Dipper. So I'm not sure that you can actually see my arrows, my pointer.
Yes,
so
I can see it.
Oh, you can, okay.
Yeah.
From the bottom two stars of the scoop, from that perspective, you're looking down to the lower left. And the thing is, comet brightness is a little difficult to predict. And so we're not sure how dim it will be at that time. But what's neat is Stellarium will give you an estimate. So if I may take a moment, right now on that date, on the 22nd, it's expected to be magnitude 10. If I come back here to the 18th, well, it's estimating at about 9.7. I found it to be brighter than that because it's naked eye for us. So we'd have to look at the atmospheric settings in Stellarium to see how much it's adjusting the apparent. Okay. All right. So let me go through a couple of the questions. Annabelle had asked how fast this comet is traveling. So the documentation I found said that it's going 57 kilometers per second away from the sun. So pretty fast.
Yes.
All right. We had another great question. Do all comets come from our solar system? Well, up to not that long ago, we would have said most likely an emphatic yes. But so far, we have one comet we're aware of that actually came from outside our solar system.
I'm getting a picture of it right now. Keep talking.
Okay, it's Comet Borisov.
Yes.
And I mentioned at the beginning of our presentation, it's rare to have a comet named after an astronomer anymore. Usually it's robotic surveys, but bam, here we go. The first one that we are aware of from outside our solar system is Comet Borisov. And that comet had said the particular part of the orbit called the eccentricity. They found that, hey, wait a minute, that thing is not going to circle around the sun. It's going to be slightly perturbed by the gravity of the sun and just keep on going. Aurora is bringing up the picture for Comet Borisov. Can anyone name the other extrasolar object that we are aware of so far? And I'll be really impressed if you're able to spell it.
I'll be impressed if they're able to say it.
So it's Oumuamua is the name of that one, which is Hawaiian for scout, if I'm correct.
I think you're right.
That one, we're still not exactly sure what it was. Some are calling it an asteroid, some are calling it a comet, last reports. Mm-hmm. And part of the problem was with Oumuamua, we caught it on its way out of the solar system. With Comet Borisov, fortunately, they caught it on the way in, so we had more time to get some telescopes pointed at it.
Yes. And I actually have a picture here too. Does this help for long and short period comets?
I am watching.
You're waiting for it.
feed,
Okay. So here, there's a lot of questions about Comet Orbits. Here, I'll talk until it catches up. They're normally divided into two different types. Short period comets are usually less than 200 years. Comets that come here usually have elliptical orbit. Comets from this category usually have elliptical orbits, and they just usually orbit just outside the orbit of Neptune. We have about 200 of them that are known, like Halley's Comet, and we think they come from the Kuiper Belt, which is currently what we know of it, that is being kept in orbit by Jupiter. Jupiter is really important in our solar system. And so it's like a giant asteroid field beyond Neptune. And long period comets, those are the ones that have orbits greater than 200 years. Those are long elliptical orbits, sometimes parabolic. Those of you math geeks out there like me, they're not confined to the ecliptic plane. You know how it looks like a lot of the planets in the sun were all in one plane. Same thing with those short period comets. The long ones, they can come in from the top down or the bottom up. They come in from this sphere that's around our solar system. And so one of the reasons we study comets is because it's a chance for us to get this material kicked in that we can study. So we don't have to go out here. It actually comes straight to us. And that's why we really, really want to know about it. Do you want to add anything, Brian? Does that help?
Yeah, no, I agree. And what's amazing is when we think about the Oort cloud, how ridiculously far away it is from everything else in the solar system.
Yeah.
And I'm actually working on pulling up another animation show that.
Here, let me know when you've got it. I'll share pictures that we took of a comet. This is that little teeny thing that tried to land on it, and it lasted for like 2 days before the batteries died, or part of it got ripped off or something. Right. I forget. This is actual pictures of a comet, which are just amazing. So this was the Rosetta spacecraft. Okay, so are you ready? Let's see.
Yeah, no, it's I thought that the NASA eyes visualization would show the Oort cloud, and it doesn't.
It doesn't.
So that's okay.
That's okay. Well, this hopefully will help. For those of you who we've had a number of people ask where do I learn how to make a comet? That was for the folks that are on. I'm sorry, I can't unshare my screen. Hang on a second. I have too many windows open.
While you bring that up, maybe I'll answer one other question.
Yeah, please go ahead.
I know it really helps to take the pressure off of one person.
Yes.
So we had another awesome question from Annabelle. She asked, how was the path of a comet predicted? And now what's interesting is when a comet is discovered, then scientists start taking measurements of its travel direction, its velocity, and from that in comes the math. And they actually calculate what's called an ephemeris, which is a list of numbers that tell us all the particulars, including its curve, is it a parabola or a hyperbola, etc. From that ephemeris, they can plug that into a computer program, and it will calculate the entire orbit and its predicted location at any time. And that's then what we do for Stellarium. We download the ephemeris for the comet, and then it calculates all that for us. And so then we had the other question too, will this comet hit a planet? Now, the farther out in time we go from where we are at this moment when we took measurements, the more difficult it is to predict mathematically exactly what it will do, but we do not expect this comet to hit anything. So save the date, about 6,766 years, we'll hope to see it again.
We're actually going to see, what's the really bright one that we had in the 90s? That one's going to be here first because it's
Halley's.
Yes, thank you. I just mentioned it, right? It's going to be here in like 4,300 years.
Yes, we'll see Halley's way before.
So here's some image. Here's a good one for you to just kind of wrap things up here. Let me share my slide again. How many on here do you recognize, Brian? Let me see if I can share. There we go. Any of these that you recognize in terms of comets?
Oh dear, I'm being tested. So I'm
Test. Do you recognize any of them?
Yeah, I'm waiting for it to come
up.
up.
You're waiting for it to come up. Okay.
Yeah.
Anybody else out there recognize any of these comets? I actually taught a class in comets to the science camp a few weeks ago. And so this is one of the presentations.
No, I don't think I could name any of these. Oh, I think it's Tuttle. I think maybe one of them.
Okay.
No.
Okay, wait. You know this one? There we go. How's that one? Especially with the name across the top.
Wait, thank you that's a softball. Waiting for it to come up. While we're waiting for that to come up, we can mention that meteor showers occur when the Earth is traveling through the path where a comet has gone and left some dust behind.
Yes.
Well, Aurora, I'm going to go out on a limb and say that's Comet Hale-Bopp from 1995.
I think you're right.
Awesome.
And, we were really bummed in 2007. We were expecting to see an amazing comet, but only the southern hemisphere got that one.
Yeah.
So you never know. We were expecting the big one, and they come once every decade or so when they choose to. And everybody gets really excited, and then nothing happens, and it gets frustrating. So, but you can see your comet tonight, and so we expect you to go out there and do your homework. Okay, we should probably wrap things up here. Brian, do you have any other last-minute questions before we announce the next stargazing and wrap things up for tonight?
Let's see. No, we'll just. I think I would bring up really quick that we do have a meteor shower that will occur before our.
Well, that's right.
Show in August.
Do you have the date of that? Is it the 14th?
Yeah, I'm bringing it up for you right now. You betcha. Okay. Yeah, so that will be the Perseids.
Okay.
And so for the Perseids, then we're looking for the dates August 11th, 12th, and 13th. And it's best to look early morning, because then the side of the Earth where you're in is actually driving straight into the path of the comet. Don't worry, the comet's long gone, so we're just hitting little tiny bits of dust.
Yeah, it's like if you have I work with kids, can you tell? So like if a kid went and ate all the cookies in the house, you would look for the trail.
That's awesome.
Right. So that's
Here's
what
a
you-
link with an article about looking for the Perseids.
Okay, great. And typically when you do meteor showers, people ask, do I need to get my telescope out? And the answer is no. There's no way you'll be able to follow the fast moving particles of dust you see lighting up in the sky. And so it's best enjoyed with friends and hot cocoa and popcorn and on your back or in the back of a pickup truck and in the sleeping bag, and just enjoy it. And you can use binoculars if you're trying to find the source, but honestly, just looking up in dark skies is best.
I agree. Some people talk about bringing a telescope with you to quote unquote kill time, but invariably you'll have your eye on the eyepiece when the most miraculous shadow causing meteor will go overhead and you're looking in a telescope the opposite direction.
Yes, happens
I agree.
all the time.
Keep your eyes open on the sky. Like you said, hang out with friends, you chat, hang out
Yes.
together, and keep your eyes pointed up.
Yes, very much. All right. Okay, so I'm going to say a huge welcome to Brian. Yay! If you guys appreciated Brian, tell him in the comment box right now. Drop it in there. Tell him how much you appreciated him. And thank you so much, because I'm going to just gush and just tell him how much I appreciate him. I could not be doing this without him. Absolutely not. So thank you for helping with today. And thank you to everyone. You know, it would be boring just with, you know, the three of us here talking. It'd be really boring. So thank you for joining us and being part of our stargazing session. And I'm really, really excited about this. Now, the next one we have planned, August 22,
Yes.
I believe.
That sounds right. Yes,
Yes.
August 22nd.
Okay,
Yes.
great. So
Same
we're,
time.
go ahead. I'm sorry.
Yeah, sorry, same time, 7 o'clock p.m.
Yes.
Pacific.
So we'll be doing this again in August. We're going to move on to different constellations and have a different handout and different things for you to look at. So the stuff we've talked about is great for the next couple of weeks. Do that. We have a few last minute announcements that I didn't get to talk about in the beginning because I forgot. The first one, I'm showing Brian. Hi, Brian. So the first one is that we will be doing solar astronomy. Gotten a number of people asking how to do that. Please don't do that at home. We're going to show you how. We have someone who has not just one, not just two, but like 5 different kinds of solar telescopes. And he's going to be with us. And so if you want to get an invite to that, you have to be on our email list because we don't know when it is yet. So we're going to send out that email to everyone. So how do you do that? You go to our website, which is www.centralcoastastronomy.org, O-R-G, or just type in Central Coast Astronomy and you'll find us. I should probably be putting this up in a text overlay. Okay, so you can also subscribe to us on YouTube, but the way you get the announcements to these things is actually by signing up on our email list. So again, our website is www.centralcoastastronomy.org, and so you can find us there. Definitely subscribe to our channel so you'll get reminders for the next stargazing events. Oh yeah, and if you subscribe, you will also get, you'll know when the next things are because it'll be done as a YouTube stream, I think. The next thing we're also going to be doing in August, we are going to be doing one of our other astronomers is going to do a week-long tour of the moon. And a lot of people, he is an amazing astrophotographer. Back when we were just using film, like digital wasn't even on the table. He actually was published more than 1,000 times. And so in magazines, publications, in fact, I was just picked up a book the other day. I kid you not, Brian. I picked up a book from a used bookstore, or I had it shipped to my house, right? Because we're all in houses now. And I opened it, and his name was in there several times as the astrophotographer. And I'm like, you got to be kidding me. And this is a book a number of years ago. So anyway, so he's amazing. And he was saying, hey, I'd love to do a presentation because there's so much on the moon that people don't even realize is there. And so he's going to do small presentations each day for an entire week. If you would like to get in on that, you need to be on our email list so he can send out his personal invitation to you as well. So again, you can find us centralcoastastronomy.org. So those are coming up in the next month or two between July and August that we're planning in addition to stargazing. So we have a lot of really fun things that are happening. Okay, so anything else you want to mention, Brian, before we're done?
I think we're good. That was a great set of announcements and a great show.
Okay, awesome. And we do have, do you want to really quick just mention our speaker next week?
Absolutely. Yes, this Thursday we have a presentation from Russ Glenn. He's the director of education for SLOO telescopes. SLOO, very funny name, SLOOH. They put the ooh in SLOO. Now, that may not be a pun unless you know that SLOO is what we describe a telescope that's moving by its motors. This is a subscription service where you can control robotic telescope, either in the Canary Islands or Chile, and they have student subscription rates that are amazing. So he's going to tell us all about robotic telescopes and about how you can take advantage of their program. So that'll be this Thursday, July 23rd. And we have the link to watch it for the YouTube. Of course, subscribe to our channel to get a notice, but then you can also have more information at centralcoastastronomy.org.
Awesome. Okay, well, thank you. Well, thank you, Brian, again. And thank you, everyone, for participating and joining us. Go ahead and drop us a note and let us know what you like best about the presentation so we can do more of that for you next time. So something we just love doing. We love sharing the skies with the community and helping everyone just go outside, look up, and just be amazed at what you see. Do two things for me now. Subscribe to our channel. And the second thing is share this with someone. Share this particular YouTube thing. Share the knowledge that you got today with someone else. That will cement it into your brain even more. And it will also help make the world a better place because now you've got more people excited about astronomy, which is what we want to do in the first place. So from our team of astronomers to you, thank you again for joining us. And if you do have questions, you can always email us. Our website is www.centralcoastastronomy.org, and we will see you next time. Thank you, everyone. Good night.